In today's webinar, we will learn how to put together an AI-enabled network video recorder using Metropolis Microservices for Jetson. We will briefly talk through the platform itself. We will talk about system services, microservices, how to install it, and how to test it. The Metropolis Microservices for Jetson, or MMJ for short, is an extension of Metropolis platform that encompasses Jetson devices. The entire Jetson ORM family built on top of Jetpack 6.0 or later will be supported. MMJ introduces its own VMS as well as metadata processing. Let's look at system services. The function of storage system services is to detect, mount, and create the file system on them. The service also sets up quotas and user groups. Redis has two functions. It is used as storage for metadata and is also used to serve as message bus for data exchange. We have included lots of monitoring constructs: Prometheus, Grafana, Alert Manager, Push Gateway, with Grafana exposed through Ingress System Service. Visual UX, including CPU, GPU, memory, and disk utilization, is also included. Network services provide DHCP configuration. They also allow for isolation of upstream and downstream network, the latter containing the cameras. Ingress is an all-encompassing service to present our APIs. It allows APIs to be selectively opened for external transactions. Cloud integration scripts facilitate the integration with your prospective cloud service. Firewall has been added to block external access to the containers apart from the configured open ports. A bidirectional, always-on TCP connection is provided by IoT Gateway system. Let's look at microservices. DeepStream is a well-known quantity that is now available as a part of MMJ. With this first release of MMJ, we introduce Video Storage Toolkit, a built-in Jetson-specific VMS system. Its function is storage and streaming of multimedia as well as sensor management. Processing of metadata exclusively is now feasible thanks to yet another member of MMJ family. Highly accurate counts can be obtained by our new gems, the tripwires and regions of interest. As a part of a complete suite of microservices, the AI NVR showcases how to put a turnkey application together quickly and effectively. AI NVR will also showcase how to leverage included microservices, AI stack, and platform software for different purposes. This is a conceptual diagram of AI NVR built on top of MMJ. It features optional cloud integration scripts that you might want to use to integrate with your own service. People detection and tracking is facilitated by PeopleNet and NVDCF respectively, both sourced from DeepStream microservice. The remaining processing is performed purely in data domain. The data processing microservice allows for a rectification of trajectory, superposition of tripwire of region of interest, resulting in very accurate counts. We also created an Android application. Source code is provided as a part of this release. Our APIs allow for direct integration with third-party user authentication and fleet management subsystems. It is possible to assemble a fully functional AI NVR using off-the-shelf components. As an example, you can use Orin AGX DevKit with 2 TB NVMe, Jetpack 6.0, and of course MMJ. For data viewing, you will need Android device, be that tablet or mobile phone. Provisioning, streaming, and statistics can be done on Ubuntu laptop. RJ45 socket must be connected directly to internet source. USB to Ethernet dongle is required for downstream network connectivity. Container will not start unless a network switch is connected downstream as well. Hardware aside, you will have occasion to use Android app as well. Please make sure that the Wi-Fi is on the same subnet as the Orin AGX DevKit. AI NVR comprises video storage kit, data processing kit, instructions to create tripwires and regions of interest. Let's go through the minimum setup. I will use Orin AGX dev kit, a simple Ethernet switch, USB to Ethernet dongle, a short Cat6 patch cable, Phillips screwdriver, and of course the 2 TB NVMe storage. First, undo the fastener screw using Phillips screwdriver. Insert 2 TB of SSD storage. Make sure it's minimum of 2 TB and fasten the screw back in. Attach internet source to RJ45 socket. Attach USB to Ethernet dongle to one of the USB sockets next to RJ45 socket. Attach patch cable to the dongle. Then attach the other end of the patch cable to the input of a PoE switch. You can then attach any ONVIF-S compliant PoE camera. Let's look at software installation process. If you haven't done so yet, please install Jetpack 6.0 on your. Please refer to VST webinar on details on how to do it. Here we will start with installation of platform or system services. Make sure that you logged in to NGC and use these commands to install the platform services. With all the platform services in place, we can now move to installing of the application bundle. Open browser and navigate to ngc.com and log in with your credentials. Make sure that you select correct team and group. You should see the following UX. Click on AI NVR and select download. Files hosted on NGC are usually zipped. You will have to first unzip to find the tar file. You will then need to copy the tar file to your target or in AGX. In this example, I'm using FileZilla to do that. Simply copy it from one window to another and untar it on the other side. Copy configuration files to the target directory of English. Follow that by copying quota files from app bundle to target Jetson config directory. We will perform the remaining setup from command line. Please make sure that you're logged into NGC. Use the following 2 commands to start storage and networking services. Then reboot the dev kit. Once the dev kit is back up, we will start the remaining microservices. Redis, monitoring, system monitoring, GPU monitoring, and Jetson ingress. We are now ready to run AI NVR application. We will use Docker Composer. As all previous parts of this video, this is also a little bit sped up. We'll now use VST and NVStreamer UI to test the installation. We discussed both at the occasion of VST webinar, so just a little bit of a reminder here. NVStreamer runs on the Ubuntu laptop and you can access it at port 31000. Go to File Upload menu and select any video that you currently have for testing by dragging and dropping it on the UX of the NVStreamer. In this example, I uploaded 3 separate videos showcasing various use cases. For example, the inside of a typical retail store, the same retail store outside, and movement of people in a subway. NVStreamer then converts those static files into RTSP streams, and you can see the addresses of those streams here. Let's copy one of those streams and use it for consecutive tests. Open UX of VST, it can be found at port 81 of the target machine, and paste the RTSP address of that video as so. Make sure that there are no spaces in front of the address. Give the stream a name so that it appears as if it were a camera. Hit submit and wait for green message box to show up on the UX. You can manage this stream just like any other on-web camera. Select live stream and look for video stream with the name you gave in the previous step. We are very excited to introduce an Android-based application designed to handle both video and data real-time streaming. I will mirror the Android application UI by using an application called Visor, so that you can see both VST web-based UX and the UX of the actual Android application. You can download the Android application directly from Google Play Store. You will see two icons, black one and blue one. Blue one allows direct connection to the box. Black one uses optional cloud connectivity. In this example, we will use the blue one. You will see RTSP streams from all files and live cameras that you pre-configured in previous step. I will select the same video that you can see on VST UX on the left. You can see that both videos are synchronized and playing live through both UIs. Click icon above the top right corner. You will see a new UX that displays both video and data. This particular UX displays real-time, full field of view occupancy. You can change horizontal scale from minute to hour, from hour to day, and also from day to week. Changing horizontal scale changes sample rate. It is 1 second in 1 minute scale, 1 minute in 1 hour scale, 1 hour in 1 day scale, and 1 day in 1 week scale. Let's go back to 1 minute. By clicking -1 or +1 minute, you can browse horizontally through the timescale. As you browse through data, you also browse through the video, which is placed synchronously with the data. The data and video timestamp is displayed between -+ buttons. This extremely flexible UX allows for quick visual analysis of traffic patterns. You can compare hours, days, and even weeks. This helps tremendously in resource planning. Let's look at another gem, the Tripwire. In orange, you will see number of people crossing per second in the direction of red arrow. In blue, number of people crossing in the opposite direction. If you click hour button, you can integrate by 1 minute. And if you click date button, you can integrate over 1 hour. Numbers in orange and blue depict integrated numbers of people for each timepiece. Just like with the field of view gem, you can browse the previous or next hours, you can see the timestamp, and you can examine patterns of traffic in either direction. This particular example shows you immediately that traffic towards the arrow is much heavier than the traffic opposite the arrow. You can check instantaneous live traffic by clicking the live button. The third gem we added is a region of interest. Region of interest is defined as a quadrangle with data visualization equivalent to that already presented for field of view. A count is reported as long as persons' feet are within the quadrangle. The vertical hairline moves steadily from the left to the right along with the timestamp and the live video. This vertical hairline is always synchronized with the timestamp displayed between minus and plus buttons, and it travels from the left to the right at the velocity defined by the scale. You can skip from analytics to analytics by using buttons displayed above the live video. Here I clicked Tripwire again. As you can see, the data is retained and you can browse back to field of view. Click the plus button above the live video to create your own tripwire or region of interest. Let's start with tripwire. Tap 4 times to position the tripwire in desired location. A red arrow will be displayed automatically. Give your tripwire a name, then name traffic in the direction of a red arrow. In this field, you can set the threshold at which you would receive alert. Let's set it to 1. Set similar parameters for the opposite direction, the name and the threshold. Tap Done, tap the green button, and look for your tripwire above the live video. Scroll left to the right to localize the name that you gave to your tripwire, and see how new accounts are being created live in either direction. Let's create a new region of interest. Tap plus, select region of interest, and give your region of interest a name. Setting thresholds to 3 will alert you every time a third person appears in the region of interest. If, just like myself, you forgot to actually create region of interest, you can do it now and click through the naming again. Scroll through the list above the live video to find the name of region of interest you have just created. Tap on it and see the new data being populated. Let's look at the location of alerts. In this tab, you can see a list of all the alerts created using rules for tripwires or regions of interest. The latest alert is displayed at the top of the list. Pull the page down to reveal the latest alerts. Let's see how to re-log into application. Swipe from left to right. Here you will see the IP address of the target box and that it also matches with the ST tab. Tap Logout and confirm. You can relaunch the application now. Make sure that you're using the blue icon. Type in the IP address of a VST. Once you tap Submit, you will be taken back to the camera feed UI. All videos, metadata, tripwires, and regions of interest are retained. Source code for this application is available as part of MMJ release. We hope that this application will let you test and deploy much faster. Quick note about available portals. You can examine the VST APIs at port 81, Push Gateway at port 1991, and Grafana at port 3000. Login using admin for username and password. Once inside, you will be able to examine statistics relating to all containers included with AI NVR application. Let's examine a couple of code samples for the Android mobile application. Let's start with how to fetch the list of attached cameras or RTSP streams. This API returns the list of cameras. Here you can see the authorization token and the device ID. The structure will return a detailed list of cameras with all their parameters. This next API returns the status of each camera. You can also see the authorization token and device ID, just like in the previous API. This is a list containing device status for all the cameras. This third API pairs camera name with stream address. As previously, we use authorization token and the device ID. We can then see list of pairs, addresses, and names. We then use the output from all these 3 APIs to obtain the list of cameras to display in the UI. Let's see how to create a tripwire. First, we will collect the tripwire details. This structure describes tripwire's parameters. In our application, tripwire is a 4-point line. Each point line is described here. Each tripwire has a specific name, ID, and for each direction of the tripwire, there is also a separate name. X and Y coordinates of each of the points connecting the tripwire are listed in this structure. For each direction of the tripwire, there's a separate trigger rule. Alerts are sent only if the rules are fulfilled. Alerts can be sent for each direction separately. Each rule has its own ID. With all the parameters of the tripwire set, we call this API to draw it. It uses authorization header and the definition of a tripwire itself. Creating ROI is not dissimilar. We need to collect ID, name, and the coordinates of polygon. For Android application, we decided polygon to be a simple quadrangle. Just like with Tripwire, we have to define the alert rule. For ROI, the alert is generated if number of people exceeds pre-programmed threshold. Each ROI and rule have unique IDs. You can then create ROI with those unique IDs and authorization header. After creating the ROI, you have to create the ROI rules by calling the entry API. And here is the API for ROI rules. As usual, it takes authorization header as well as set of ROI rules. For last example, we will examine how to fetch data from one of the gems, in our case, field of view. There's only one field of view per camera, so the only thing that we need here is camera ID. You then specify time interval, beginning and the end, as well as granularity of data. Regardless of specified granularity, data is collected each 1 second. You can specify lesser granularity, for example, every 1 minute, in which case you will obtain the maximum occupancy observed during that 1 minute. With all the parameters in place, you can now call this API to obtain the count. As always, you will find a ton of very exhaustive and useful information on DevZone. There's also a dedicated VST webinar. There are lots of FAQs, troubleshooting steps, as well as specifications of hardware pieces that we tested internally. Those include OnDevS cameras, NVMe drives, and mechanical hard drives. I hope you enjoyed this webinar. Best of luck putting together your own AI NVR, and I hope to see you during forthcoming GTC.